quickly. Alrighty. Your title is Trigonometry and Pythagoras, and today we are looking at Pythagoras in 2 dimensions and then 3 dimensions.
Is the notes?
Yes, in your notes. And then, yeah. You guys can't. Why are you complaining it's hot? You've all got jumpers on.
I don't know, but it's cold. I've got a cold. I'm going to try and keep warm and cold.
And underneath the title, draw 2 of our triangles. Sure. What do you want? Alright, so fundamentally we have 2 different sorts of Pythagoras problems. Either the hypotenuse is the unknown, so x is on the hypotenuse here, or it's not. Now, just to recap from previous years, the hypotenuse is the longest side of the triangle and it's always directly opposite the right angle. So in our case, you should be able to see the right angle and opposite it is the hypotenuse. Alright. Now, approaching either of the problems is exactly the same. Essentially, what I would like you to do is label the 2 sides that are not the hypotenuse A and B. Good question. No, it doesn't. And then label the hypotenuse C. And you can use different colours if you like. Alright. And then we write the Pythagoras equation, which is a squared plus b squared equals c squared. And then we look back to our triangle, and where we see A, B and C, we should also see next to it either numbers or are unknown. So we simply put in or substitute in those numbers. So for A, we would substitute in 3, for B we substitute in 4, and for C we substitute in x. So in our Pythagoras equation, instead of A we write 3, and instead of B we write 4, and instead of C we write x. And note the squares stay there. Alright. And now you can reach for your calculator to help you with this bit, or you can start doing mental arithmetic. 3 squared is 9, plus 4 squared is 16, equals x squared. 9 plus 16 is 25, that equals x squared. And then, does anyone know how we get rid of that x squared and make it just an x?
Square root of the answer.
Yeah, we square root both sides. So we can say the square root of 25 equals x all by itself. Now note that my x is on the right hand side. It doesn't matter which side of the equation it's on. You can write that as 5 equals x or x equals 5. Traditionally we go with x equals 5. It's just what convention says, but both of them mean exactly the same thing. Alright? Now, our process is almost exactly the same when x is not the hypotenuse. Once again, we label the sides A, B, and C. Rewrite the Pythagoras equation. A squared plus B squared equals C squared. Then we make the substitutions. So C becomes 13, A becomes 12, and B becomes X. Now we have a different issue as we had before. Before, we had all the numbers on one side and all the x's on the other side, which is fantastic. However, here, there are numbers on both sides. And really, we want x all by itself at the end. So we need to get rid of that 12 squared. How do we get rid of it? Jade? Good, we take it from both sides. So we're going to subtract 12 squared from both sides. I'm not sure if you guys are used to doing that working. Subtracting 12 squared from both sides. In previous years, would you have just written minus 12 squared on the other side? Alright, either way, as long as it's clear what you're doing. And now you're left with x squared equals 13 squared minus 12 squared. And once again, you're always welcome to reach for your calculator, but 13 squared is 169. 12 squared is 144. X equals 169 minus 144. X squared is 25, and we've seen that before. So we square root both sides again and make it x is equal to the square root of 25, or x is equal to 5. Okay. Now it's quite likely that it won't always come out as a perfect number. So it won't always come out as square root of 25 or square root of 36, where x is equal to 5 or 6 or 4 or 3. What's equally possible is that it can come out as x is equal to the square root of 17. Now, when it does that, what I'd like you to do is either that is your answer. Square root of 17 is just a number. You can leave that as your answer. So you can say x equals 17 centimeters. Or you can go to your calculator and figure out that square root of 17... Whoa, that's not 77. Is 4.123105.6, and it goes on forever. And at some point we've got to stop. So traditionally we stop at 2 decimal places. So you'd write 4.12 centimeters. Either of those answers is fine. Right. If you then go on to use this number in other calculations, so working out the cost of fencing of a perimeter, for example, I'd like you to either use the square root of 17 or a big long number like that. It just reduces the rounding error. Okay? But if you're just trying to find the length, then x can equal square root of 17 or 4.12. Make sense? So, up the top we had two forms of Pythagoras questions. Either r unknown is the hypotenuse, in which case we do on the right, on the left, or the unknown is not the hypotenuse and we have to do a little bit of rearranging before we get started, before we get the solution.
Hello.
Hello, Jack.
I have this.
Excellent. Glad to see you made it. In a second when these guys start questions, I will give you this for notes. Sure. Alrighty. Are there any questions about this? I think you did Pythagoras for the first time in Year 9? something like that, and it was kind of hasn't changed since then? No. Alright, so we'll go through this practice quickly. What I'd like you to do is those 5 problems, and then we'll do Pythag in 3D, followed by 3 more problems, and then you can go to your folio. Okay? Yeah, you guys like the meme?
Did you make that?
No. Oh, someone else made that. There's someone else like me out there. How good is that? Now, essentially, Pythagoras in 3D doesn't have to be any harder than it is in 2 dimensions. You just have to know where the right angles are. And part of that is being able to visualize what's actually happening and then draw the triangles off to one side. So, see 3D Pythagoras, think, draw a 2-dimensional diagram. Because as you've all been practicing with 2-dimensional Pythagoras, it's not too hard. Yeah? It's nice and systematic, you just plug your way through it. Now imagine this is essentially the shape of our room, and we want to find the distance from H to B. It's like going from up there to down there. Now, if we only know each of the sides, we can't just find exactly what it is straight away. And to do that, well, to find HB, we need to do a couple of intermediate steps, which work when you visualize this picture as having 2 triangles. Yeah. So you've got one right angle triangle in the bottom corner here, and because we have AD and AB along there, we have both dimensions of that blue triangle that can get us that bottom dimension there. You can get us essentially the diagonal length of the floor of this room. Yeah? And then once we've got that diagonal length and we know the height, we can then find the diagonal right across the room. So our plan is to find this one first, yeah, along the floor, and then from corner to corner we're going to do that. Alright? So our first triangle is going to be the blue one, and the blue one's corners are A, B and D. See that from the diagram above? And the right angle happens at A. So what we've really just done here is we've taken this triangle from our 3-dimensional... Huh?
Do you want us to draw those?
Oh, can you?
Yep.
Alright, give it a shot.
Yeah, it doesn't look really the same.
You drawing it doesn't look the same?
No.
Alright, I can't draw. I've just taken them straight off the internet. Sort of cheating, but it makes it easy for you guys to follow.
So from A to D is that 3 centimetres?
Good.
And then the others are...
Yeah. So Jamie's going on to our next step, and that's putting measurements into our 2-dimensional figure if possible. So from A to D is the same as length BC, so that's 3 centimetres, it goes here. And from A to B we know is 9. And we're wanting to call that unknown Y. So from a slightly confusing three-dimensional picture, we've taken out a two-dimensional triangle, and now we can solve it using Pythagoras. So once again, we label the sides A, B, and C. Write A squared plus B squared equals C squared. We substitute in the numbers, so 3 squared plus 9 squared equals Y squared. Three squared is 9 plus 81 equals Y squared. Y equals the square root of 90. And we can leave it as that for now. So now we go back up, and this time we want to aim for our final solution, which is finding the longest diagonal in the room, so that's HB. And HB is part of this triangle here. And at what point is the right angle? Where's the right angle in that yellow triangle?
In the corner, in D.
D, good. Because if you imagine drawing a line along the floor and that meets the wall, it's a right angle there. So our triangle here will become HBD. Now for the measurement, we know the height. The height is 4 centimeters. Yeah, that's the height of our room. The distance along the floor, dB, we've called y, and we've found what y is already. And y is root 90. And we can use root 90 there. It's by far the easiest thing to use rather than all those decimals. And then our unknown along the diagonal is x. So once again, from our three-dimensional triangle, three-dimensional image, we pulled out a two-dimensional triangle. And we solve using Pythagoras. A and B, C. Write Pythag. A squared plus B squared equals C squared. A squared is 4, so 4 squared plus square root of 90 squared equals x squared. 16 plus, now what's square root of 90 squared? 90, yeah. And your calculator will help you there if you can't remember that one. So 90 equals x squared. 106 equals x squared. X equals the square root of 106. Okay. One more example. Oh, any questions on that? On where we got the triangles from, or how we use Pythagoras? Yeah. Lovely. Alright. Can you all have a go at that one then?
In our notebook or?
In your notebook. In your notebook. I'll go through the answer in a second. Note that it gives you EB. EB is 5.76 and it wants x, which is the height of ED. Alright. I'll go through on the board. So,
You're waiting. Can you wait?
alright, I'll wait a couple of seconds.
What did you get?
Is this right?
Yeah, that's what I got. Well done.
What did you say the answer was?
About 2.69? You got it?
Spotted.
Alright. So you did 3.6. That would be right if this here, that line there, was 5.76. Because then you'd have 3.6x and 5.76.
Yeah.
Problem is, that line isn't 5.76. Our 5.76 is EB. It's that line there.
Yeah, I got it. That's what I did, that line there.
Yeah, but then what's the height? What's like the base? Where'd the 3.6 come from?
There. I don't know.
So the triangle you're using is that, and where's the 3.6 line?
Yeah, I just dragged it down. I just thought.
So you thought that would be 3.6
Yeah.
if those two
I worked
are.
out this one.
Yeah.
Here
Unfortunately, you
instead of
thought
that
wrong.
one there.
So what is
I worked out the big one.
So what you had to do was find out that one first, and then use it with that and that. But to find that one, you
Oh, you
have
have to do another triangle first.
another triangle here. I'll go through it now with everyone. Alright, so how to solve these is a bit confusing because it's difficult to see which triangle our unknown is part of. What you can do is highlight your unknown. That's what we want to know. And then think of all the right angle triangles that are possibly connected to what we already know. So there are a couple of right angle triangles connected to it. There's this one. There's this one along the diagonal. And there's that one. Alright? Now, in order to find an unknown, in order to find x, we need the other two sides. Okay? Now, all of those highlighted in yellow, we know two of them. We know this one, the 3.6, and we know the other one over here, which would also be 3.6. Okay? The other thing we know is this hypotenuse there. I'll take the highlight away because it looks confusing, but we know that because the question tells us in 5.76. Alright? So if we know that this one here, and we know we can find the diagonal along the base of the room, so the BD diagonal, then we can get the other two sides of the triangle involving x. So essentially our plan is, or what we need to do, is to use this triangle here to find this line, and then we're going to use this triangle here, of which we'll know y because we'll have worked it out, and we know EB because it's given to find x. That makes some sense? It's sort of similar to our last one, where we had to use an intermediate triangle to get where we wanted to go. Alright, so we want to draw two-dimensional figures. Don't like red. And this is going to be our first triangle, which will be B, C, D. Now it's important I put the C there because the C here has the right angle. Our right angle is there on the floor. And then the sides are 3.6, 3.6. And some people might think that if both of those sides are 3.6, then the last one is also. But that's not the case. Alright? We label it our unknown, y, and then we use Pythagoras to find out what it actually is. A, B, C. A squared plus B squared equals C squared. 3.6 squared plus 3.6 squared equals y squared. And then you work out that in your calculator. That finds us our y. So now which triangle are we going to draw in 2 dimensions? What are the vertices of it? What's our second triangle for finding x? It was highlighted in sort of a bluish colour. It's going to be DBE, and D has the right angle. And the bottom, the line between D and E, is going to be RY, which is 5.09117. Our height, we don't know, that's X. And the diagonal is given as 5.76. And then you guys can all do the Pythagoras along with me. The heat in here is making people tired. Alright, so can you please finish those questions in Pythag on 2D, and then we'll do questions 1 to 3 of Pythag in 3D, and then you can do folio. Should have time to get on for a good 15-20 minutes of folio towards the end of the lesson.